Hello everyone and welcome to the third episode, I think we should call them episodes, of the Project Euler, in which we're going to continue our journey to solve the Project Euler problems. Okay, so look at that. My mouse disconnected. That's a good thing. How are you today? Let me see if everything's right. Let me know if you can hear me. Let's see. Alright, I think we have a bit of a delay, so yeah, just let me know when you can hear me. For those of you who don't know, my name is Florin Pop. I'm a software developer, engineer, programmer,
Hello
coder.
everyone and welcome to the third episode.
Yeah, that wasn't good. Sorry about that. Alright, yeah, I was checking the stream too. Okay, good. So apparently it works. So yeah, as I was saying, I'm Florin Pop. I'm a software engineer. I have a YouTube channel. I do coding tutorials and live streams. And on freeCodeCamp, I started doing these Project Euler challenges, I think 3 or 4 weeks ago. And this is the third part. We did the first 5 in the first stream. Then we did the next 7, I think. And now we're going to continue. I don't know how far we can get. I haven't prepared. I mean, I didn't want it to have the solution ready so that we can solve them together. Which is good because we can see how's the approach. Maybe we have to Google some things to learn about collets, I guess. We're going to see when we get there. Yeah, this time the chat will be opened, so make sure you don't spam that much. Yeah, so Project Euler, I saw someone asking what Project Euler is. So it's a series of challenging mathematical or computer programming problems meant to delve into unfamiliar areas. By the way, I'm not an... Oh, yeah, so my mouse apparently wants to die today. So basically it's coding challenges, and on the freeCodeCamp curriculum we can do it in JavaScript, which is nice. If you haven't saw the previous live streams, I suggest you go and look over, and also you should start looking at them on your own and then maybe check in with us to see how it's going. All right, let me see. I have here another battery to change my dying Mac mouse. Just a second. Hello everyone. I see so many people. That's crazy. Okay, let me change this. Yeah, sorry about that. I didn't know that my mouse is being fancy today. Let's hope it won't die again, or I just have to use some other batteries. All right. Well, if I think the chat has a 30-second delay, so what I would suggest you use the chat is for questions, and okay, let's see if this works now. For questions, and if I get stuck, maybe you can help me. Last time Lauren helped me a lot, so okay. So my mic does my mouse doesn't want to work, which is fun. We're going to start with a pause. On the freeCodeCamp, we're going to use JavaScript. So okay, let me get some new batteries. Just a second. Will this work? And okay, just give me a few seconds. I'm going to... All right. I had to go to get a new pair of batteries. Sorry about that. Yeah, it is a delay from the chat and the live stream, so keep that in mind. I'm not sure what's the latency, but it might be a delay of a couple of seconds up to even 20 seconds. So it depends on how they set up the stream. But yeah, all right. Hopefully now the mouse won't die again. See, this is a developer's journey. Sometimes your mouse will die when you need it the most. Okay, good. Taking too long to replace the batteries. Yeah, I'm doing my best, buddy. All right. So let's see the problem we are going to start today. It's the large sum. What is it about? Whoa, look at all these numbers. Okay, let's see. Work out the first 10 digits of the sum of the following 150-digit numbers. Okay. So I think we need to add up all these numbers and keep track of the last 10 digits. Okay, let's see. We also have here a test nums. All right. I think what they will provide us is just this big number. Yeah. But although I see here is an array. Oh, 150-digit numbers. Okay, so we have these numbers which will be inside of an array. And we need to add them up and only return the last 10 digits. Popper Army reporting. Hello, Arpan. Okay, so how will we do this? What I'm thinking is that we basically only need the last 10 digits of all the numbers. We're going to add them up and then store the result in a 10-digit number, right? I'm not sure that we need all the numbers. So, for example, this part, because they'll add up and do some things. I don't know. Let's see. So we have 3, 6, 9, 10. For the test number, we get oh, the first 10 digits. Okay, so not the last. For some reason I thought that it's the last 10 digits. Okay. So then we kind of need to add up all the numbers. And we go up and store the less than. Yeah, first and not less than. Okay. So let's see. Laura, do you have any ideas how we can approach this? I guess we can keep adding the digits. The good thing is that they all have the same number of digits, right? So we can kind of go one digit at a time and store the result. Yeah, some people in the chat are kind of rude, so don't do that. I'm not sure why. This is not, as I said, I don't have the solution from the beginning. We're going to do it on, at the first go, and we're going to see the approach and how we what's this? Well, what's the way to get to the solution? So yeah, good. Let's start by doing this approach. We're going to loop over the string, get the numbers, and add them up in a ending number, in a result number. So let's see how that works. Result number will be a string. Well, or we could use an array. Let's try that. So we're going to have an array, and we're going to take, in the test nums we have 2 strings, which is good. So we have 50 digits. We can go for let I 0 I less than 50 I plus plus, and here we can get digit 1 will be well, we kind of need, let's see, we know that in test nums we have 2 strings, so we can do something like array of 0, and the index will be, let's see, array that length 50 minus I. So 50 minus I, right? Because I is 0, we want this digit. Then I is 1. You said at the beginning you don't need all digits. For every number, the most relevant digits are relevant to the sum. Well, yeah, we kind of need all the digits, right? Because they might add up and change the last, well, the first 10, right? So let's try that. So digit 1, digit 2 will be array of 1, so this string, and 50 minus I. Okay, so we have the 2 digits and we want to add them together. So result num we're going to push digit 1. Well, let's just keep 1 and 2. 1 and 2. It's 1 plus 2, right? Now, this will work. So here we're going to have 0 plus 8 will be 8. 5 plus 3 will be 8. 2 plus 5 will be 7, and so on. The only issue will be, for example, here where we have 4 and 6. When we add them up, it will be 10. So we have 1 extra for the next, for the next addition. So we need to account for that. Okay, let's see. We could use a boolean to keep track of that. So has, well, maybe over 10 and will be false. So if 1 plus 2, weird variable numbers, but let's work with this and see how it goes. If 1 plus 2 is bigger than 9, so it's 10, 11, up to 18, we want over 10 to be true. Otherwise, over 10 will be false. And here, when we push, we kind of want to keep track of that also. So 1 plus 2 plus over 10. If we have over 10, we want to add 1. Otherwise, we had 0. Right? But then here we also need to account for that, right? We might have, so let's see, we have 4. We have 9 plus 9 is 18. So we move 1. Let's see an example here. Yeah, so this is the perfect example. 4 plus 6 is 10. So we move 1 here. And then 7 plus 2 is 9. But with 1 from the previous addition, we have 10 again, right? So let's create a sum and do 1 plus 2 plus is over 10. We can do this ternary thingy. So then we add the sum, and then we check if the sum is bigger than 9. If it is, then we set it to true, otherwise we set it to false. This should work. So at the end now, we're going to have an array. Let's see, result num. And let's console.log it. Here we should have an array. Oh, they're strings. Good. So we need to convert them to strings. Sorry, from strings to numbers. Yeah, not a number. Okay. 50 minus 0, so we don't have an index 50, we have an index 49. So minus I minus 1. Thank you, Arpan, in the name of freeCodeCamp for your donation. Yeah, thank you. Yeah, it's kind of a bummer. Some people are just mean. Yeah. And you can see other issue we have now. We are pushing the 2-digit numbers into the sum. And we don't want that. So we can do modulus 10. And then it will cut off that part. Okay, so now, hopefully, if we did a good job, we have the correct calculation for these two numbers. And let's see, so we start from the right, and we need to end up here. So the first 10 digits, we have it the other way around. So the last 10 digits here. Let's see, do we have something? Yeah, look at that. 8, 3, 4, 8, 4, 2, 2, 5, 2, 1. So we have the answer here, which is good. Which is pretty good. We just need to get it out, right? Okay. So instead of returning the result num, we want to do result num dot, let's see, slice minus 10. So the last 10 numbers, we want to reverse it like that. We want to join it as a string like that. And we want to convert it to a number like that. So now if we run this test, we should solve the first one here, which is good. Yeah, that's true. By the way, for those of you who want to chat and also want to support this nonprofit, which is very helpful, I think they helped hundreds of thousands of developers. Well, I guess even millions with the articles and everything. I don't know the numbers exactly, but it's very helpful. I promote them a lot. If you want to support it, you can become a member, and then, well, you will be able to chat in the live chat. Okay. Good. So we kind of have it for one, well, with two numbers. What we have here is, let's see, 150 digit numbers. So let's see. We can do it with the pairs of 2, right? I'm thinking. Yeah. So we can kind of do it with the pairs of 2 and then keep adding to the number. Let's see. But when we add all of them, the number will get pretty big. So it will be more digits. Here we have 50 digits, but at the end, we're going to have probably 51 digits, 52 digits even, I don't know. So we need to account for that. Let's see. We could store the result number in this array. Well, we could store the first number, right, in this array, and then add the second one to it, the third one to it, and so on and so forth. And at the end, we're going to have this big number. It's just that we're pushing here. So that means that we kind of need to push again Yeah, it's not the best approach. I'm thinking how we can do that. Because we don't want to lose the first 10 digits. We could change the digit of the index instead of pushing. So this works with 2 numbers, but with more numbers it might get bigger, and we need to count for that. Or there is a better way. Can't think of a better way now. So let's do it manually once. So we're going to add these numbers, then these numbers, and so on and so forth. And at the end, we're going to have a number from these 2 numbers, right? Which, as of now, will be pushed in this array. But then we kind of need to use that array and add up this number. And the only issue with this approach we're having now is that, well, we kind of go over only 50 digits, but the sum might get bigger. I know that in Node, I think there is a big int library which could save us, but I'm not sure here. Because if you just add the numbers, so if you do something like, let's see, test nums of 0 plus test nums of 1, well, this is concatenation, we can convert them to numbers. Yeah, you can see that we have plus 49. But we kind of have the... Do we have the 4 digits? Oh. Okay. We kind of have the digits here. Arpan, welcome as a supporter. Thank you on behalf of freeCodeCamp. Yes, so I think we we overcomplicated this. Let's see. I'm going to comment this out just to save it for now. And we're going to return. Let's do the good old reduce. We have the accumulator, the item, and we want to add to the accumulator the number, parse int item. And we want to start with 0. All right. Let's run this and see what we get. Well, we kind of need this big number. What happens if we say to string? Okay, and what happens if we do think substring 0 to 10? Amazing. I don't know. Let's see. Substring. I always have to look at substring. So I want numbers. I think it's with like splice from 0 to index. Well, doesn't seem to work though. Substring 2? Not really. So what's happening? Doesn't it work for toString? Let's do this in the console, as we can see exactly what it looks like, if it's a string or if it's a number. Okay. Whoa, look at all this. Because if we have a number, 8 plus 8, it's this color, say purple. Nice. But if we have 8 plus 8, well, we have the codes. So we can use this array like that, and we can apply the reduce on it. like that, and you can see that we have a number. So now if we do toString, oops, yeah, we get a string. So what if we do substring now? Or yeah, let's see, 0, 10. Okay, so here it works, which is good. We kind of want not 10, we want 12, because, well, we have the dot too. It's inclusive. So we want this, and want to replace the dot with a string. Yeah, look at that. So we add this, although there are strings, and we get a e plus 49. Not sure up to how much it goes. And then we use the reduce to add up all the numbers inside the accumulator. Then we convert it to string. We get the 11 characters we want, and we replace the dot. Seems to work. Let's see. We use this here. So yeah, basically what I did at the beginning, it was pointless. Although you can see that, oh, the console log doesn't work because we're having this. Oops. So we don't have the call of the large sum. My bad, sorry. Large sum with the test nums. Yeah, look at that. Good. The only issue is that it's not a number. And we can convert it to a number adding a plus. Whoa, look at that. It was much simpler than I originally thought. Pretty crazy. Yeah, sorry about that. Okay, so we add up all the numbers with reduce. We convert the string to a number, and then we convert it back to a string. We get the first 11 characters, and we replace the dot. Okay. I think if we save this, and we go to the next one, I just want to see if it will remain saved. Okay. Overcomplicating at the highest. Yeah, it doesn't. Oh well. I guess we just have to download the code. Good. Doesn't matter how big the number is at the end, you need the first 10 digits. I would throw away the very small digits. Not sure what you mean with that. Alright. Good. So let's see the longest collets. Sorry if I mispronounce your name. Or, I don't know. I think it's a name, right? Who is this guy? Let's. Or maybe not a guy. It's a conjecture. Oh, okay. Okay, let's see what it says. So the following iterative sequence is defined for the set of positive integers. N becomes half of n if n is even, or n becomes 3n plus 1 if n is odd. I've heard this before. Using the rule above and starting with 13, we generate the following sequence. So this is odd. Okay. And we end up to 1. Yeah, I saw the download button. I just didn't click it. It can be seen that this sequence starting at 13 and finishing at 1 contains 10 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Although it has been proved, well, it has not yet been proved, sorry. It is thought that all starting numbers finish at 1, which starting number under the given limit produces the longest chain. Whoa. The chain starts with terms are allowed to go above 1 million. Once. Okay. So let's read it again, because my English is not the best. So which starting number under the given limit, so we have a limit, produces the longest chain. Note, once the chain starts, the terms are allowed to go above 1 million. Okay. So this is interesting. We need to find which number produces the longest chain. Okay. One way would be to do the brute force and check for all the numbers, create the sequence, and then see which is the longest. But we kind of don't want to do that. I have another idea in mind. So yeah, if we do let's start with that, but you'll see that it will time out eventually. So we have the limit, and we need to start which starting number under the given limit produces under. For let I equals 1, I less than the limit, because we want under the limit, we want to check the sequence. So let's see, we're going to write a function which will do the calculation, and it will check to see how long it will take, right? Okay, let me think. So let's write that function. Check length. I'll check let's length of the number. Okay, and here we can do a while number is different than 1, right? Oh, and I guess we can start with 2. We want to do this thing here. So if it's even, if number modulus 2 is 0, we want to do number divided by 2. Yeah, thank you, Laurent. By the way, let me know what's the delay of the chat. Let me know when you hear this. Probably they need to set up a lower, not sure how it's called, just so it will be faster. Okay, so if the number is even, we want to divide by 2. Else, we want to do 3 times number plus 1. So this will be while is different than 1, right? Okay, if number is 1, then we want to return 1. This will, I guess we can say get its length. Otherwise, we want to say here length, which will be 0. And here in the while loop, we'll increase the length. Plus plus. And we're going to return the length like that. Okay. Good. Now you'll see that this won't be the best approach, because for every number we're redoing all these calculations and it will time out. But let's just start with this and then we can adjust it. Okay. Oh boy, it's pretty pretty delayed. Okay. So we want to return the number for which the length is the longest. So we want to save the number, well, the number. This will be, I don't know. This will be 2 by default. And then we want to say the max length will be 0. So here, we're going to get the length from the get length of the I, which will be the number. So we're going over all the numbers, right? Up to the limit. We get the length, and now we're going to check if length is greater than max length. Then we want to do 2 things. First, max length will be length. We want to reassign the max length, and we want to change the number. I just added the number. I don't know. It's not the best, but we have the number here, so I want it to be special. And the number will be I. And here at the end, we can return the number. Let's console.log this, and this should hopefully work. You can see that for 14 it works, which is good. Whoa, it worked for all of them. Oops, yeah, I guess. Well, I was thinking that it will be way too many calculations, because for this number, for example, it will go up to 1 million. So for all of the 1 million numbers, oh, you can't see that. Why? Oh, okay, so up to, I guess. Oh, you can't see that. Sorry, let me remove this. So for 1 million numbers, it will do all this. And it should take a lot of time. But apparently it runs and it works. So then, we shouldn't worry. I was thinking about doing an approach where we kind of store the numbers and their lengths. So, for example, we know that from 5 to 1, it will take 1, 2, 3, 4, 5 steps, right? From 13 to 1, it will take 10. So I was thinking, your Mac is too fast. I'm not sure if it runs on my Mac or on their servers. Yeah. So what I was thinking is to store these numbers, and whenever we go over a number and we already have it, so for 16, I don't know, let's for 2, for example, we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah. So for 13 we have 10, for 2 we have 2, right? Although it's weird, we only have one step, but okay. Oh, it accounts for the chain, never mind. So if we store the 2, having the length of 2, its chain to be 2, then whenever we find 2 again, we can just use that, right? For example, for 5, we know that we have a length of 1, 2, 3, 4, 5, 6. So we would just use it. Whenever we get to a number which is 5, instead of doing the calculations again, we already knew that for 5 it's 6, right? Memoization. Okay, thank you, Laurent. Yeah, something like that. But because it works, yeah, something like a cache. So I was thinking to have a big object with key value pairs, the number on the left and the length on the right. And we could always check if we have that number in the object, then we could use. Probably a set will work better, but I haven't worked with set that much, so oh well. It works like this. That's a challenge for you. If you want, do the second approach. I will just move on because it will probably take a lot of time. And well, I guess we better do another one, right? Okay, let's see. Lattice paths or lattice paths. Hopefully I did not mispronounce it. Starting in the top left corner of a 2x2 grid and only being able to move to the right and down, there are exactly 6 routes to the bottom right corner. How many such routes are there to a given grid size? Okay. This is interesting. I have no idea how to do this. Yeah. I think this will be the end. Lauren, do you have any idea how we can approach this? Oh boy. So, I'm thinking now. We start here. Here we have two choices. Then here if we reach here, we have two choices. Here we only have one choice. I'm 100% sure that there must be some kind of algorithm, but I don't know which one. What I have in mind is using a matrix, well, and just checking all the possibilities. Let's see. Yeah, this is fun. Okay, so can we find out how many approaches are there from the points? So here we have 1, 2, 3, 4 points, which can go two ways. And 1, 2, 3, 4 points, which can only go one way. And that's 6. Let me write this down. For a 2x2, do we have tuples in JS? I solved it with arrays of positions like x0, y0, and a start. Tuples, not sure. I don't really know what those are also. Okay. So we don't have a lot when it comes to 4. We have 6 routes. For a 4x4, we have 70 routes. That's a lot. For 20, we have that number. For 9, we have 48,620. You solve it with arrays of positions. How far are you? I see you've played a lot with Project Euler. How far are you? So we could do with x and y as you said. Let's see, so this will be 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, and 2, 0, 2, 1, 2, 2. And yeah, I don't really have a clue how we could do that, because let's say we are here, right? So we can go to the right and down. And well, when we go to the right, we can only go one more here. These problems are getting harder and harder. Let's see, if we, as I said, from here we have two directions, here two, here two, here two, and just one there. We kind of have an 8. What will be the result for a 3? I'm thinking if we can kind of use that number somehow. Because there must be a formula. I'm sure there must be a formula. I'm just trying to guess what could it be. I'm very curious what's the number for 3. And maybe we can see a pattern. Should I start drawing those? Yeah. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 now. A position like 0, 0 plus move right is like adding 0, 1. And if move down, it's 1, 0. But yeah, but then you have 1, 2, 1, 2. Or will you go here also and let's see, 1, 2. But then you kind of end up to 2, 2. Nah. I wish we had the solution for 3. Maybe we could find a pattern then. 1, 2, 3. 1, 2, 3. Yes, there's a formula too, but it's super advanced math, and I do not understand it. Yeah. 1, 2. How many? Can you run your? I wouldn't want to draw for 3 by 3. Could you run your script and tell me how many rows we have for 3? And maybe then I can think of something. Help me out here, Lauren. This is why I wanted you. Maybe we can find some kind of formula or a way to think about it. Kind of have something, but yeah, for 3, yeah, I'm going baby steps. This is interesting. Let's see what Google says about lattice paths. Maybe we'll read some documentation and Nordice lattice path. In combinatronics. Lattice path is in, whoa, a lot of things here I don't understand. I'm not a very mathy person though. Keep that in mind. Lattice paths are often used to count other combinatorial objects. Similarly, there are many combinatorial objects that count the number. Yep, yeah, I see something here. Okay. Yeah, pretty interesting. Northeast lattice paths have close connections to the number of combinations, which are counted by the binomial coefficient and arranged in Pascal Triangle. Okay. 4 by 4, it's 70. 4 by 4, it's 70. Okay. Is it cheating because I'm looking this up? Hope not. It's not. We make the rules. So I see the Pascal triangle here, which is you have ones on the sides and then you kind of add them up as you go, right? So 1 with 1 is 2. 1 with 2 is 3. 1 with 3 is 4. 1 with 5. Okay. 4 with 6 is 10. 5 with 10 is 15. 15 with 20, 35. 35, 70. Okay. So the numbers on the diagonal is like, yeah, you can see here we have 6, which is for 2 by 2, right? 6. And then for 4 by 4, sorry, I think for 3 by 3 we have 20. And for 4 by 4 we have 70. And I think with if we go down this road, we get the numbers. So let's see the next one. 5 by 5 will be something like 6 plus 21. 6. Okay, let me think again. So here will be half 6. Here we're going to have 6 plus 15, which is 21. Here we'll have 21 plus 35, which will be 56. And 56 plus 70 will be what? 126. Here, but we need this number. So that number will be 126 times 2, 252. We don't have 4, 5. But I guess that will be the number. Okay. But how can we code this? Our approach will be, well, pretty much the same, but the other direction. Here we have northeast, but we want southeast, right? So down and right. I'm thinking of an approach to have an array. Let's see. So we need a triangle, which will look something like this. 1, 1, 2, 1, 1, 2, 3, 2, 1. Right? Yeah. 1 to 1. Wait, no. So 1, 1, 1. Okay, so I missed a couple of steps. 1, 1. And then we have 1 to 1. And then we have 1, 3, 3, 1. Okay, so they add up. So 1. Does anyone understand what I'm doing here? Something like this. So the next one will be 1, 4. Sorry, this is 3. 6, 4, 1. Right? So we kind of need to go down this tree. And we get to our result. This will be our fourth. So the center of this number will be the 2 by 2, which is 4. Nah, no. So for 2, how can we find this? So 2 by 2 is 4, and we have the 5th row from the pyramid, I guess. Let me move. Can I move everything to the right? Yeah. I want to do the next one and the next one, so 2 more. Okay, 1, 5, 10. Oops, this kind of, I'm going to put 0 here. Well, a star. A star, 5 and 1. And here we have 1, 6, 15. Well, 15 will be this. Here we'll have 30. No, 20. 10 plus 10. So 20 will be x. I'm going to write down what we have here. 6 and 1. Okay, so we have star to be 10, pound to be 15, or no, that's the hashtag. X to be 20. Okay, so if we want the 3 by 3, 1, 2, 3, 4, 5, 6, 7 in the 7th number here in the center. So this is what we want for 2 by 2. This is what we want for 3 by 3. Oh, 1, 2, 3. Okay, so they kind of go in an odd number of fashion, I guess. This is for 1 by 1. 2 by 2, 3 by 3. Okay, now how can we convert this into code? We need this pyramid. And if we find this out, we're going to solve the problem. It will be another approach that you took, Laurent, but oh well. We should eventually reach that. Okay. I'm thinking. So here we have an array with 1 digit, with 2 digits, 3. Yeah, an array with one number, 2 numbers, 3 numbers, 4 numbers. Good. So our array should look something like this. So first one will be this. Yeah, this is the well, let's see. I don't want to mispronounce it again. Pythagorean yeah, Pascal's triangle. Okay, good. So we can use that. Good. So first one will be that. The second one will be 1, 1. The third one will be 1, 2, 1. The fourth one will be 1, 3, 3, 1. Okay, how can I get from this to this? Think. So we could kind of start with an array which has this, just the 1 and the 1, 1. And then when we construct the next array, we do this plus this. Nah, doesn't work. We kind of have always, except for the first one, we have ones on the sides. And then the middle, this one will be this two. But then this one will be this two. Okay. Your was brute. Yeah, probably your was better. And just, I don't know, doing the baby steps to hopefully get there. Okay. So I have an idea. We start with this array, and for the next items, we go over the elements, and well, when we construct this array, we'll put 1 and 1 at the ends, and in the middle, we're going to go over this array and add up the numbers, right? Now, when we construct this array, we put 1 and 1 on the ends, and then we add this 2 and this 2. And so on and so forth, right? Good. So then we're going to have the pyramid, and our answer, oh, I kind of got it. So our answer will be, let me think. So the array DFS with backtracking. Yeah, I think. Thank you, Michelle, for donating the £2. Thank you in the name of freeCodeCamp. Yeah, probably that will be a better approach, but I don't know those. I think starting with these problems, I kind of have to learn more about all the algorithms and stuff. But yeah, thank you for joining and for donating. Okay, so yeah, where were we? Good. So we're going to have our Pascal triangle. I could just, well, I couldn't do it for all these numbers. But yeah, we're going to start with this. And the next item. So first we need to figure out how many items we want to have. And then when we create the last, see, so this is the answer for the 1 by 1. This is the answer for 2 by 2. This will be the answer for 3 by 3. Sorry, so 1, 2, yeah. This will be for 3 by 3. Yeah, exactly, 20. Okay. So we need this Pascal triangle length to be, let's see. For 2 by 2, we want it to be 5. For 3 by 3, we want it to be 7. 1, 2, 3, 4, 5, 6, 7. So 3 times 2 plus 1. 2 times 2 plus 1. The next one will be 4 times 2, 8 plus 1. Okay, good. So we're going to do a for loop for let I will be 0, and we're going to go up to grid size times 2 plus 1. And we're going to start with index 2 because we already have these 2 there. Good. Now, in the Pascal triangle, we want to push something. Okay, I forgot here. I++. So we want to push something. This something will be the new array which we need to construct based on the previous array. Yeah. Kind of hacky, but hopefully it will work. So prev array will be, well, let's just call it triangle. Or just call it 3. Easier to type. 3? 3, I don't know. Try, I guess. Of index I minus 1. So we're going to get this array. And for this array, we're going to use the previous array. And we want to do something with it. Create next line using the previous line. Let's call it that. Hopefully it makes sense for you. It does in my mind, but who knows? Okay, and the next, create next line. We're going to use a line function. And here, so what we want to do. First, we want to have a line array. No, so we get that line. New line. We'll have an array of 1 and 1. And in the middle, or you know what? We can do it like this, have a 1 and new line that push a 1 at the end. So we have this part, right? Okay, and we need to construct these numbers. So how are we going to do that? We have a line. We want to go over the line. So for let I0 I less than line dot length. If I could type I++ length. Okay. And here we want to add const new item will be line of I plus line of I plus 1. So this one and this one. And then in the next loop, if we are here and want to construct these two, we get these two and then these two. Okay, and we want to go up to the last number. So we don't want to get this because we don't have a number after it. Okay, and the new line, we're going to push the new item. Then we push a 1 at the end, and then we return the new line. Does it make sense? Hopefully it does. Let me comment this out. Let me console.log this. And now, if we did everything right, at the end here, in the 3 array, we should have this. Look at that, how beautiful. I like it. Okay, and what we're searching for is pretty much this number. So the last array, the middle number. So const last array will be try dot slice minus 1, and const middle number will be last array of index last array dot length. So let's see, this one is 1 2 3 4 5 6 7 8 9, and we want the element at index 0 1 2 3 4. So divided by 2 and math.floor, right? 9 divided by 2 is 4.5, then we delete the 5 at the end of that 5, and we get the middle number. Last array. Okay, something's not good. So we slice. Let's see the last array. Oh, so it's... Oh, I see. So we don't want to slice here. We kind of want to get the last item. My bad. So 3.length minus 1. Okay, good. So then we have the last array or the last line. I think we can use that last line just to be more thoughtful about it. And then the middle number will be 70. Okay. Yay, look at that. It worked. Yeah, a lot of thought process about it. Well, behind it. And we kind of needed to see this. And when we had that, well, yeah. So, might be cheating, maybe not. We did it. Well, we didn't copy anything, so we created our own. So, yeah. It's not cheating, right? Okay. I hope everything's working, so we can go to the next one. I kind of want to download this. Let's see. Yeah, good. Save that there. All right. Yeah. Hopefully you got it. It was probably the hardest one we did so far. Okay. Let's go to the next one. Hopefully it will be easier. All right, so let's see. Problem 16. Power digit sum. 2 to the power of 15 is 32,768, and the sum of its digits is 26. What is the sum of the digits of the number 2 to the power of? Okay. This will be interesting. I guess if we do console.log here, so we see the result, and if we do math.pow 2 to the exponent. Okay. Thank you, Laurent. So for 15 it works, for 128, yeah. So that was something I was afraid of. And for 1000 we get this number. Okay. And we need to add up the digits of this number. We have here e plus, so this number has 302 digits. Pretty nice. Pretty nice. Not really, but yeah, okay. What happens if we do divided by 10? So I'm thinking if we could somehow get the digits. Okay. We could use mod 10 and divide it by 10 to get the digits, I think. But yeah. Okay. The big number will be this. And the sum will start with 0, and while the big number is the big number is what? So we keep removing a digit. So for example, if we have E15, we want to remove this digit, add this digit to it, remove it, so on and so forth. So while this number is bigger than 0. Cheating will be to use the formula directly. Routes equals... Okay, so let me copy this. This will be the formula for the previous one. So 2 times n factorial divided by n factorial times n factorial. Okay, this is crazy. Nice. Yeah, so this was the formula for the previous one. Pretty clever, but who knows? I knew they had to be some kind of formula, because at the end is Pascal's triangle, and it has all sorts of crazy things going on. Okay, let's get back to this one. So while the big number is bigger than 0, we want to do something like that. Sum plus equals big number modulus 10, and big number divided by 10. Well, I guess we can do mat.floor big number by 10. Is big only. Okay. It's read only, not big only. All right, so sum 26. Okay, this works for this number. This should work for 128. Yep. So we kind of missed there something. Yeah. What about 1000? Okay. So something is not working correctly. What is it? We kind of lose, I think. What if we don't floor? Yeah. We want to chop off digit. How can we do that? It should work though. Yeah. So it chops off the numbers, but yeah, let's also see const last digit will be this, and we add this. I want to see what's the last digit also. Will it get it right? 6402466448. Hmm. 006. Why is that 6? Oh. Oh, well, yeah. That's weird though. Yeah, so see, here it works, here it works, here it works, here it doesn't work anymore. That's weird. Why is 8? Oh. Why is this 6 and this 8? Is there some JavaScript issue there? Or who knows? Or you know what? I could, instead of doing this, I could just say toString and substring -1. And here we're going to add the last digit like that. Okay, so apparently no. Substring substr. Okay, good. Yeah. This seems to work better. I don't know these numbers though. So hopefully these digits are good. Yeah, not really. You can see that it gets this plus 38. So we don't want that. What could be another approach? I still get confused why it didn't work with modulus 10. I'm thinking what could we use? Let's see. Something else I want to check. So modulus 10. What's the difference? We have 56 and we need 166. So it's a 10 digit different. A 10 difference. Here is 8, here is 8, here is 6. So that's probably the issue. I don't know how else could we do. Because we get this plus 38, so we don't get full number. With big ints, we could have done it. Do we need to convert to an array of digits and just store everything in an array? I wouldn't want that. I'm thinking. So if we do that, we start with 2 and then we multiply by 2. We get 4, then 6. Yeah. So multiplication with 2 is like adding the same number twice, right? So if we have an array with these digits and we want to have, well, the duplication of this, we just add this number again. And we can add each number with each number like that and create a new array. The reason why I want to convert this to an array because it will be easier at the end to use reduce and get all the digits. Although I'm still yet surprised why modulus 10 doesn't work. Maybe because the number is too big? Weird. So I guess let's do that approach. I'm thinking, so we're going to have some arrays. We start with 2, then 4, then 8, then not 16, but either 1, 6 or 6, 1. Then we have not 6, 1 plus 6, 1. So 6 plus 6 will be 12. So we keep 2. 1 plus 1 will be 2, and with the 1 before will be 3. And if we do this approach, at the end we're going to end up with, well, this number, but in an array. And then we can just add up the digits. So how we do this? So we go over the digit, and we multiply it by 2. And if the number is bigger, the next loop will get +1. Okay. Kind of tricky, but yeah. Let's keep this here. And I'm going to do this sort of thing. How far we need to go? Well, we're going to use a for loop. Okay. So let array will be a 2. And for, let me push this up a bit. For let I less than 0, I equal to 0, I less than exponent. So if we have 2, then we multiply it once. Okay, that works. Good. So now we want to go over the digits of the array, multiply them, and if it's bigger than 10, we want to move the digit. We kind of did this before, right? So yeah, array.for, that I think we're going to change this array, because when we get from 8 to 6, 1, which is 16, we kind of need to push a 1 there at the end, which will be interesting. Oh well. So for let j equals 0, j less than array.length, j plus plus. And here what we want to do, so array of j will be array of j times 2. Good. If array of j now is bigger than 9, want array of j to be array of j modulus 10. So we chop off the, well, second digit, and we want to keep track of some kind of boolean. Let over 10, we kind of did this before. This will be false, and if that's the case, then over 10 will be true, else over 10 will be false. Okay, so we multiply it, reverse the array. Yeah, I want to rather push to then pop, because the multiplication is kind of from the right of the side of the number, right? If we have something like 1248 times 2, you do something like this, right? So we do 2 times 8 is 16. Oops. And then we keep 1, and 2 times 4 is 8, plus 1 is 9. Then we have 4 and 2, right? So that's kind of the approach you do. This is why I'm doing the numbers reversed. So when you multiply, you just go, well, hope it makes sense. Okay, so we multiplied. If it's bigger, then we chop off the digit, and over 10 is plus. Okay, and we kind of want to do the same thing here again. So yeah, new value, I guess, will be this. plus over 10. If it is, then we'll add 1, otherwise we add 0. And the new value will be this. And if the new value is bigger than 9, then we chop off that digit and we add it to, yeah, okay, good. So over 10 will be true, so we add it next time. All right, good. This should do something. Not sure yet what. Let's return the array and see what we get. A 2, okay. It definitely didn't work. So why is that? J, so it goes over the array length. Nope. It should go. So it goes once. Oh. So we kind of want here if over 10. So at the end, if we still have over 10, then we want to do a array that push 1. So yeah, good, finally. So this works now. What we did is that, so we have 2, 4, 8, 16. So when we had 16, we kind of did 8 times 2. We added 6, but then we didn't have 1. So we kind of want to push 1 at the end. And now hopefully, well, if we do, let's see, 2 to the power of 10 should be, okay, that's 2 to the power of 11. Yeah, so 2 to the power of 10 is 1024. 2 to the power of 10, yeah, 11 is this. So we're off by 1. Why? Because we start here. So let's do -1. Okay, good. 2 to the power of 2 is 4. 2 to the power of 3 is 8, 16, 32, and so on. Awesome. So we have all the digits now, even for this big number. Look at that. And at the end here, we want to use our dir reduce method, accumulator item plus item 0, and voila. So this just adds up all the digits in this array. Well, all the numbers. And there we go. For 1000, we have 1366. For 128, we have this. And for 15, we have this. If we run this, should work. Let's download it. And move on. Well, let me go over again. Hopefully you understood it, but let's see. We can remove this. Although I don't know why this didn't work. Why I didn't get the last digit correctly. But nevertheless, we just create the number and edit the digits in an array. And do the calculations, and at the end we add up all the numbers. Hopefully this makes sense. It does in my head, but yeah. All right. Let's go to the next one. How much time we have left? We could, let's see the last one, and if it's too hard, we're going to leave it for the next one. For the next session. If not, we're going to do it today. Let's see. Number letter counts. Okay. If the numbers 1 to 5 are written out in words. Oh boy. 1, 2, 3, 4, 5. Then there are 3 plus 3 plus 5 plus 4 plus 4 letters in total. If all the numbers from 1 to given limit inclusive were written out in words, how many letters would be used? Note, do not count spaces or hyphens. For example, 342 contains 23 letters, and 115 contains 20 letters. The use of AND when reading out numbers is a compliance with British usage. Is in compliance. So, okay, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 23. 3 plus 7, 10, 13 plus 8. 10, 6 plus how many? 7. 13 plus 1, 2, 3, 4, 5, 6, 7. Okay, 7, not 8. 20. All right. Okay. Good. But not so good. Let me drink some water. Okay. The good part is that we only go up to 1000. Inclusive, yeah, limit inclusive. So, yep, I'm thinking. We have so many variations. So let's write them down. 1 is 1, 2 is 2, 3 is 3, 4 is 4, 5, 6, 7, 8, 9, and 10. And then we start with 11, 12, right? 13. Let me know if I write them wrong. 14, 15. Hopefully I write them wrong. Right. I haven't wrote them in a while. 16, 17, 18, 15. This doesn't look right. 15. Yeah, okay, so it's 15, not 15. Okay. $19 and then 20, 30. The good part is that we start with these. 40, 50, 60, 70, 80, and 9. Okay, which one did I mess up? Hopefully it didn't, because, well, pretty much these are all the different ones. Starting with 100, well, 100, then we have 200, 300, 600, and we can kind of use this. So if you have 638, 700, 54, so on and so forth. But if you have 0, oh boy. And we don't have 0. Let's start with 1. Okay. I'm thinking. Let's just get some random numbers and see if we can find some fancy way to do it. So 876, 800, and 842, 115. Okay, so we get the and also when we have over 100. So many conditions. We could check if we, well, by default 100 is misspelled. Yeah, 100. Thank you. We could start by checking, well, what's the length? Well, I guess if a number bigger than 100. If that's the case, then we already have 100, which is 7 characters. Then we have the end, probably. Yeah, if it's bigger than 100, 101, right? 101? I think it's end. Yeah, okay. 100 and, so that's basically whenever we have over 100, then we have like 10 characters already, which is good. We can get rid of that. Next, the only issue will be with 1000 here, but yeah, that's another story. If number is 100, well, we can just return 10. 100, right? 100. I'm just trying to think about some conditions we could use. And if the number is 1000, 1000. How do you spell that? 1000, right? 1000. So that's 8. Let's return 11. Oh, wait. So yeah. Oh yeah, so it's good. It's good because then we need to add them up. Okay, good. Wait, what's there? Good. Now, if it's bigger than 100, we'll start with 10, and then, well, we need to get all the digits. Let's see. Digits will be the number to string. This will convert it to string. We want to have an array of numbers. Use modulus. Yeah, but the thing with modulus is that, so for the first one will work, right? Although if we have the second digit is 1, then we kind of need to use this kind of thing. Other than that, yeah, that will work. So what I want here is the digit. So we have all the 3 digits. Digits of 0, this will be the first one, so the hundreds place. We can use this. So if we have this as an object, count, something like this. And for all of these, instead of 1, we have 3 here. Well, we have the numbers and the letters, right? So here we have 3 for 2, 5 for 3. So cumbersome though. But I guess baby steps. 3 for 6, 5 for 7, 5 for 8, 4 for 9. Okay, good. So that could work because now we have the digits of 0 and we could use this count. So we can have count of digits of 0 to be added to the sum. Kind of, right? Because, for example, if we have 800 and something, we first add, 800 could be a fixed number, so we don't, yeah. All right. Think. Yeah. So many things to think about. I wonder what's the prettiest solution for this problem. Oh well. So if we have 800 and something, we already added 100 and to be 10, and then we kind of add, so if we have 700, the digit of the first place will be 7. So 7 is, well, 5. Weird, but yeah, it works. So we add 5 to the sum. Now the only issue is that if we have exactly 700, then we don't have that end. So I guess we can check here. If number modulus 100 is 0, because, well, wait 1 second. So this accounts for 100 and here we don't have the end, no end, because we have exactly 700, 600. So we can start here with let sum equals 10. And here we can just do sum minus equals 3. So we kind of remove the end. And here no end. Because it's a fixed number, so 800, 700. Otherwise we have 700 and something, right? Okay, good. So we accounted for that. Okay. Now, we did for that digit, the first one, which was easier. We are bigger than 100. Okay, so we have 3 digits. The hundreds digit. Then for the tens digit, we have the digits of 1. Now this will be tricky. If it's any number other than 1 and 0, then we're going to use these. Oh boy. Okay. Because if we have 890 something. But I guess this will be... I'm thinking. Yeah, it's just so brute force. I don't really like it though. But yeah, let's continue and hopefully basically all of this will be a function to get word length. We'll get the number, and here at the end we're going to return the sum if we have any sum. Otherwise we just return whatever we want. Well, whatever we have. Okay, let me do this too. So for 10 is 3. Yeah, I don't like the approach though. So many test cases. 11 is 7. 12 is 7 also. 8. 7 again. 9. 8. 8. Then here we have 26. 6. Do we have any other special numbers we need to worry about? 5, 5, 6 or 7? 7. 7. No. 6. And 6 again. Okay, this, well, we have this here, but oh well. We already know that this is 7. Okay, so what I want to do is whenever we have, so here we have the tens digit, right? Tens digit. If the tens digit is bigger than 1, then we already can use one of these, right? So we can do sum plus equals count of digits, well, count of tens digit plus 0. This is the property of the object we want, which will be, well, 7, 0, 8, 0. Okay. Now, else if it's 1, we need to do all of these thingies. The 11 and 19 could be an array with index 1 to 9. Yeah, maybe. Special case. Yeah, well, we already have them here, so I guess we'll work with these object properties. So if it's 1, we kind of want the count of tens digit plus the, well, the last digit. What's that? The last digit. I don't know how it's called. So digits of 2. Last digit. So hacky. So hacky. Well, and the last digit, we kind of want to string it. So last digit. So if we have something like 1, 7, sorry, this is not else if 1. So if it's 816, so we want 6, 1 and 6, 16. And well, else it's 0, so then we go to sum plus equals count of last digit. So if we have 806 and 6, 806. But here again, we could have 0. Oh, but we kind of checked that there. Okay. All right. So we don't have to worry about that. We don't have to worry about that. Now we kind of did, probably, if we didn't mess up anything, we did the numbers over 100. And this kind of does it over, well, 10. I guess else if, just to be clear, digit is 0. Then we just add the last digit. Okay, yeah, something's wrong here. What's wrong? Oh. All right, let's try our function, which should hopefully give us the right answer for this and this. Hopefully, let's see. Console.log get word length of 342. Sum is not defined. Good, that's a start. Wait. Sum. Yeah, okay. Let sum equal 0. I don't know. So now it's defined. 21. Close, but not really. It's bigger than 100. Its modulus by 100 is not 0, so we don't subtract. So we have 100 and good. So that's 1, 2, 3, 4, 5, 6, 7, and 10. Yeah, okay. Next, we split the digits. Let's see, digits. What we have here. 3, 4, 2. Good. Here the sum will be 3. So okay, 15. Why 15? Console.log. We put 1 here in the sum, and here we put 2 in the sum, just to keep track. Okay, so it's 10, then 3. Yeah, this is 5. All right, good. So that's good. Next up, we want to see, so 340. So it's bigger. That means that we go here. 3 sum. 3 plus sum. So we get 40, which is 6. 40. Okay, good. Oh, and we didn't do the last one. Well, I guess this is just the last digit. So if a last digit is bigger than 0, we just do this, right? Okay, 2. 1, 2, 3. Good. Now what's wrong? 40. Oh, not 40. 40. Sorry. Yeah, and then this is. Wait. What I did? So 40. And this is 5, and this is, I guess, 14. 40. No, that's with y. 14. Okay, so that's 8. All right. So we get 23, which is 23, which is good. Let's see, for 150, we get 24. 115. Yeah. So we go here, we add this. Yeah, I guess if it's 1, then we need to do this. If the digit is 1, so 1 is 15. We don't care about the last digit, but otherwise we kind of care. So if a tens digit is different than 1, then we do this. So hacky. But it works, which is good. Oh boy, started to get tired. So for 14, yeah, I guess all of those should work. What else? Let's try for 667. So let's see, 667. So we have 3, we have 7, 3, 5, and 5, with a total of 10, 23. 23. Good. Okay, so apparently this works. Now the only issue, well, one of the issues is that we don't account for numbers less than 100, for which we kind of need to do this thing. Okay, so let's remove this from here and do it here. Digits is not defined. Okay. Because we did the digits here. Okay, so let's do the digits up here. It's getting so complicated. It's hard to keep track, and it's probably buggy. But oh well, so if that's the case, digits of 1, 0, I guess what we could do is get the digits and reverse them. And now instead of digits of 0, we have digits of 2, because it's the last one. If the number is bigger than 0, then 100. If it's 100, yeah, that's good. If it's 1000 and it's 11, okay, we can keep that. And now instead of having tens digits the same, but this will be 0. All right, so now we kind of reverse the number, and we first check if it's bigger than 100. We add what we want for 100. Otherwise, we kind of do our thing with digits and less digits and all that. So let's see for 5. We should get 5. 4, 5. Oh, 4. Good. What about 17? 9. Is that true? 17, 9. Yay, look at that. What about 10? 3. Okay. What about 110? So 110, which is 3, 7, 3, 3. So that's a total of 16. Wow, so it works. What about 1000? 1000. Hopefully that's 1000. So 3 plus 3, 6, 8, 11. All right, so let's do one more. What about 67? So 67, which is 5 plus 5, 10. Look at that, it works. Okay. Yeah, so we have the special cases. We have another console somewhere, this. But now this function should hopefully work properly. And we can kind of go over here. So let sum for let I is 1, I less than limit, I plus plus. And here we just get word length of I and sum plus equals and return sum. Okay. And here we console.log the sum, which were 5 is 15. All right, so it's not good yet. Let's see why. Okay, const length will be this. I want to debug it, so I put it here, I add it here, and then I do console.log I and length. I want to see all the lengths. Okay. Oh, I see. It didn't go up to 5. If that's the only issue we have, then it's great. Look at that. Awesome. What about 150? Well, let me remove the console. Nah. We missed by 4. Okay. What about 1000? We missed by 20. So probably one of these is messed up. 30. How do you call those numbers? So 11, 12, 13. 13? Probably some of it is messed up. And probably that's, 16. Hopefully that's the issue. Otherwise, 96, 100. Well, we kind of don't use this, so bye-bye. Let me go back to this. Okay. What would be the issue? 4 characters difference, so 9, 8, 7. So yeah, just something very, very, very so it's a number which only appears like 4 times. Whoa, look at that. I got it. Now this is 6, not 7. And this is also 6. Look at that. Nice. So that was the issue. Perfect. Okay. This was totally mess. But, well, we kind of have it now. Which is good. Let's run the tests and let's download the solution, save it, and never speak about it again. I'm so curious how someone else did it. Let's see, on Project Euler.net, here we can yeah, don't know my location. We can go to this numbers letter counts, and I think I need to sign in. Let me do it off screen, although I'm not sure what's my... I have no idea what I used. But I guess let's register. You win the spelling bee contest. For a non-native English speaker, I am pretty happy. Okay. I want to create a new account here. I think here on the platform, if we submit, okay, so username taken, so I can create that. Let's see. Ah, awesome. So I managed to log in. You can see that I did a couple here. So what I want to do, go to 17. Let's see. If the number, how many would, if all the numbers from 1 to 1000 inclusive were written out in words, how many letters would it be? So we already have the answer, which is this. We can check. This platform only gives you the problem, and then you need to submit the number. All right. So now we can go to the archives and wait. And see how else people did it. I see there are a lot of Java, C, C++. Can I check JavaScript for some reason? I think, yeah, I had some issue. Sorry about that. I had to restart the Mac. But yeah, this will probably be cut off from the live stream. Yeah, but I'm back. Yeah, so we were looking at what some other people did to solve this. Hopefully I'm back. Let me know if you can hear me. Yeah, okay, I can see myself. Alright, sorry about that. So yeah, you can see here that one person, Ari Mojo, did something similar with what we had. If it's less than 20, if it's less than 100. Okay. And oh boy, it's Python, I think. Can we have something I know? But yeah, pretty similar approaches. Can we find JavaScript? Probably no one did it with JavaScript. Let's see. This page? Nope. On this page? Yeah, I won't check all the pages. Oh well. Yeah, so unit to word, decimal to word, decimal to word. Yeah, probably smarter than I had, but yeah, oh well. All right. Thank you all for joining. I'm sorry for the interruption at the end. Hopefully, yeah, it should have picked up. Yeah, let's run this, submit, and we completed that too. So today, whoa, look at this. Why don't I have my... That's weird. All right, yeah, good, now it works. So today we completed 5 more challenges, which were pretty tough, especially this one. No, this one. This one was the toughest. But well, with a bit of Googling and thanks to our Wikipedia buddy, we could find out one solution to solve this. All right. Thank you all for joining. I hope you enjoyed it. I hope you learned something. Feel free to continue the challenge. Feel free to do them on your own. Next week, we're going to continue and see how far we can get. Thank you all for joining. Have a good day, and I'll see you next time. Bye.